Hi students, for this topic we will focus on continuous probability distributions. So we have altogether 5 learning outcomes for this chapter. First learning outcome will actually revisit what is continuous random variable. Second learning outcome will focus on how to identify properties related to normal distribution. And the third learning outcome will actually use the area under the standard normal distribution to determine the to determine it from the z values. And the fourth learning outcome, we will find a probability for a normally distributed variable by actually converting the x variable into the z variable, which is known as the standard normal variables. And the fifth learning outcome, we will identify how to calculate confidence interval for mean. So the first learning outcome here focuses on how to identify a continuous random variable. So basically we have known from our previous chapter that random variable is either discrete or continuous. So the previous chapter we focused on discrete random variables. And for this chapter we will focus on continuous random variable. So continuous variables are simply variables where all the values of the variables between any two given values of the variables are actually considered. So for example, height of an adult woman. So height of an adult woman would be like example 168.5 and 175 or 173.3. So it's possible to have decimals for continuous random variables. And another, say we use rats in the lab, so like body temperature of rats, so it's like 36.9, 35.9, right? It's continuous data. And cholesterol levels of adults, so it's given in point form, say like 5.6 or 11.1 and so on. So another thing is that many continuous random variables are normally distributed because we assume they are approximately normally distributed variables, and they form, if plotted into the function, they will actually form a bell-shaped curve, and these are known as normal distribution variables. So the second learning outcome, we will actually focus on what are the properties of a normal distribution. So normal distributions are actually family of curves, right? So you have never learned how it's a function of a normal distribution, right? So basically normal distribution, if you plot the function of a normal distribution curve, it will look like a bell curve. It will be symmetric. You draw a bell curve which is symmetric on left and right. Okay. Ideally, you should be able to determine the mean and standard deviation, because this bell curve is drawn based on the value of mean and standard deviation for a particular population, and the axis of symmetry is always at mean. Okay, and the spread is determined by standard deviation. This simply means like mean plus with 1 standard deviation to the right, plus 2 plus 3 standard deviation to the right, and also plus 1 plus 2 plus 3 standard deviation to the left, right? So the standard deviation determines how is the spread of the curve. So generally, if the standard deviation value is higher, then your curve is more spread. If the standard deviation value is lower, your curve is less spread. Okay. And the point of inflections are always 1 standard deviation to the left and to the right of the mean. Okay, and area under a curve, which represents probability, and you have learned concept of probability, is always 1. You can't be having a probability value higher than 1. Okay. Next, this is actually the bell curve that I was talking about just now. As you can see, all the criteria explained. This is the function of a normal distribution. This is the function that leads to this curve, and I explained just now the function value depends on the standard deviation and also the x values here. The mean and the standard deviation are the main criteria of a normal distribution. Yeah, So you see, this is a normal distribution. This is a normal distribution. This is the bell curve. It's symmetric if you fold it at x equals to mu. Can you see this is the axis of symmetry? If you fold it into half, it should meet. It's called symmetry, and the axis of symmetry is x equals to mu, right? Mean. And 1 standard deviation, 2 standard deviation, it can be 3, 4, 5 standard deviations to the right, and also -1, -2, -3 standard deviations to the left. Okay, it is symmetric, so therefore the percentage here is quite fixed. You see 34, 34, it mirrors each other. Okay. So for example, how do you read out probability? Percentage here represents the probability, and sum of this is 100%. If you sum these percentages up, they will give you 100%. It's 50% on the right and 50% on the left. Okay, so probability of, so this is a distribution of a variable which is known as a y, yeah, as for example. So y larger or equal to mean. Okay, larger or equal to mean. The probability of y being larger or equal to mean is over here, right? And this one will give you 50%. 34 plus 13.5 plus 2.5. And probability for y being between 1 standard deviation to the left and 1 standard deviation to the right. That means probability which is in between this area. Okay. So this will actually give you this area here, yeah. I'm not shedding the whole thing. You understand, yeah? It's between 1 and 2 standard deviation to the left and right. So it will be simply 34 plus 34. So it will become 68%. When you write probability, you don't write 68%, you actually write it in value less than 1, so it will become 0.68. Same goes for 0.5 just now, yeah? Okay, and probability for being between 2 standard deviations to the right and 2 standard deviations to the left. So it will include this. It will include this. Sorry, I shaded a bit out. Okay, so it will give you this whole area that is in yellow, that I've shaded yellow. So it will be 34 plus 34, 68 plus 13.5, 13.5. Right, so it is 68 plus with 27. So it will simply give you 95%. Okay, this is an example of how a real life application is for normal distribution. For example, female and male adults' heights are well approximated by a normal distribution. YF here means a variable y for female. That means y is height for female, adult females, is normally distributed. And CN, this is the mean 63.7, and this will be the standard deviation. So ideally, when you plot this, and this should actually give you a bell curve, because it is approximated to be a normal distribution. So same goes here. Y variable is height of adults, M is male, okay, is normally distributed with mean 69.1, and the standard deviation is 2.6. So these two are example of normal distributions.